It is now my pleasure to ask Maria Banda to introduce this evening's keynote. Maria Banda est une boursière Trudeau qui pratique le droit international à Washington aux États-Unis. C'est une spécialiste de la responsabilité de protéger la sécurité humaine. Maria est diplômée de l'Université de Toronto, de l'École de droit de Harvard et de l'Université d'Oxford. Comme M. McCall-McBain, c'est une boursière Rhodes, mais elle est unique parce qu'elle est une de nos boursières Trudeau préférées. Venez, Maria.
Bonsoir, mesdames et messieurs. Climate change, as we have just heard, touches on many different aspects of the work that we do in the Trudeau community, from ecology to intergenerational justice. But it is also an issue of state security and human security affecting communities from the Pacific Islands to Canada's Great North. It gives me great pleasure to introduce one of the leaders in the field of complex climate risk assessment and strategic planning for energy and environmental hazards, Dr. Chad Briggs. Dr. Briggs is the strategy director at Global and a US-based consultancy. He's also an adjunct professor of security studies at Johns Hopkins University, as well as a senior fellow at the Institute for Environmental Security in The Hague. Dr. Briggs was the Minerva Chair of Energy and Environmental Security at the Air University of the United States Air Force in 2010 to 2012. In that capacity, he led a team of researchers in identifying and assessing critical risks and vulnerabilities to military operations and strategies. The Minerva projects were central in defining vulnerabilities and in climate and disaster security for the entire US security community. His team also worked closely with militaries in other countries, from Brussels to Baghdad to Ottawa, and conducted theater-wide assessments and scenario planning for European Command, Pacific Command, and NATO. Prior to this appointment, Dr. Briggs also worked in several senior positions in the United States Department of Energy. He was the team leader for abrupt climate change and security. He was also the senior advisor for international security affairs and was also special advisor on climate change and strategic assessment. Dr. Briggs's research is wide-ranging. He has examined post-conflict environmental health and energy reconstruction, particularly in Iraq and the Balkans. He has also studied disaster planning in Asia Pacific and in the Arctic, and he has also looked at integration of energy and environmental risks in joint planning and intelligence operations. His work has appeared in a wide number of publications, including geography and medical journals, as well as military strategy and climate change journals, and he's currently working on a book on a NATO-related work in Ukraine. Dr. Briggs is also a global scholar in a literal sense of the word. He has studied in 9 different countries and was twice a Fulbright professor to Berlin and Budapest. He holds a PhD from Carleton University in political science, and I would be amiss not to mention on his long list of distinctions and achievements that he's also a landed immigrant to Canada. So please join me in extending a warm welcome to our keynote speaker, Dr. Chad Briggs.
Bonsoir, good evening, ladies and gentlemen. Thank you, Maria, for that wonderful introduction. And I sincerely appreciate the opportunity to be invited and speak here to such an important foundation for Canada. And thank you to Elizabeth Dowdswell for coming, who was in at least a past life a fellow colleague at the Institute for Environmental Security in The Hague. My studies of climate change really started in Ottawa, and I'd be remiss if I didn't thank Canada in general, if not Carleton, for really setting me on this path and for enabling me to study in ways that I don't think would have been, to be honest, possible in the United States in the same way. And I'm also happy to say that some of my best American students followed that path and have gone to Canada, and in at least one case, a Canadian who I convinced to stay here. So what I'd like to do is to really emphasize that the environmental security field in general owes a debt to this country, its universities, and the history of leadership in environmental risk and policies. And what I'd like to do tonight, before you're allowed to eat, is really to focus on the lessons that these security risks have, and the fact that they are as important to Canada as ever, not just politically, but in terms of real impacts. I'd also like to explain why and how climate security is so important to the United States in terms of its military and security communities. While many of you might have heard the reports concerning the Pentagon's interest in climate change, too often I think it's misunderstood why they are interested. And the more interesting story is what such work means for environmental and energy policy. We're frequently told that the future is unknowable, that we need to focus on the here and now of jobs, economic growth, and these other Rumsfeldian, quote-unquote, known knowns. And while these are important, we can't lose sight of the vulnerable points in our system, and that if we plan only for the most probable risks, we'll continue to be surprised by how quickly and how badly disasters hit us. Last year at this conference, Cleo Pascal gave an excellent presentation on how climate change affects different systems, and how, for example, changes to geography have serious impacts on politics and economics. Cleo's been an invaluable colleague since we worked together at the US Department of Energy some 6 years ago, and her examples of cascading risks should be kept in mind for those of you fortunate enough to have been at the conference last year in Montreal. My own specialty is in developing early warnings of such cascading impacts, of how, for example, changes in the Arctic sea ice affect risk to US disaster operations in the southern Pacific. We have to be able to explain not only how an earthquake off the coast of Japan can lead to major changes in German nuclear policy, but we have to be able to do it in advance. And most of all, we have to ensure that people actually listen to us. The message has to resonate, and we can't simply be placed in the role of a Cassandra. So tonight I'd like to focus on 3 things. First, I'd like to explain what climate security means, and what we might expect if, as a society, we continue to operate as if nothing is wrong. Second, I'd like to discuss what we can do to assess risks that seem so complex and so full of uncertainty. In essence, why waiting for more information is no longer a valid excuse for inaction. And then I'd like to finish with discussing some of the obstacles and opportunities that come from tackling climate security, including here in Canada. Now, we can start by admitting that the scale and speed of climate change has taken us largely by surprise. When I was a student at Carleton in the late 90s, we still thought that climate changes were largely something to worry about later in the 21st century. And even then, temperature changes would likely be marginal, maybe a degree or 2. Few of us really understood what those temperatures meant for security. The discussions at that time, which were largely dominated by the University of Toronto, focused on potentially violent conflicts as the result of scarce resources. But we did know that the largest impacts would be felt by the Arctic, in this sense by peoples such as the Inuit, the Sami, Nenit, Alutiiq. When the US Department of Energy started its climate security team in 2008, we agreed that the Arctic was the first place to look. And in large part, this was because in the preceding years, our collective knowledge about climate change has multiplied at a frightening rate. Although climate change had been receiving increased attention, the predicted rates of change were nothing short of astonishing. Rather than being a marginal issue to be addressed later in the 21st century, climate change had suddenly become a pressing and very real issue. The challenge was in translating this climate change into real impacts. Very few of our existing security and political frameworks were suited for answering these questions. Because rather than security risks being threats that other countries imposed on us, climate change was unique in that it was our own actions that posed the threat. So how could we securitize an issue that we ourselves had created? After all, we had met the enemy and they were us. Now, equally problematic was the complexity of the issue. And this has been a source of inaction now for many years. How do we make predictions about the future when there's so much complexity and uncertainty? Isn't it better to wait until we have full information before we take action? Now, first, let me make a slight distinction between forecasts and foresight. With forecasts, we're used to getting specific predictions about the future, such as weather, and we're equally used to those weather forecasts from Environment Canada being wrong. But forecasts take a specific snapshot of the present and then try to extrapolate it into the future. It's the idea that the future will be very much like today, just more so. Foresight is a different exercise, and it's one more commonly found in military and intelligence communities. With foresight, we understand that people have multiple visions of the present, different views, different interests. And these multiple visions affect what choices we make about where we go in the future. In other words, foresight clearly lays out that we have choices and that we have to be ready to deal with not one, but multiple paths that lead to different futures. Climate security is very much a foresight exercise. The job then is to help identify which areas are most vulnerable and where we should set our priorities in order to avoid the worst outcomes. We can't deal with everything at once. In practice, climate security approaches also reject the idea of preparing only for the most probable outcomes. Rather, we understand that combinations of factors are what make the future dangerous. Now, for example, Hurricane Sandy was not just a tropical storm. Now, it's common for Atlantic hurricanes to form and follow the Gulf Stream. They go out to sea, they only perhaps give a glancing blow to Newfoundland on their way out. But Sandy was a disaster because of a combination of factors, including a surprisingly high pressure system south of Greenland, and this itself was likely climate change related, that forced the storm to shift west near New England. Also at work was an Arctic front meeting the storm around New York, a full moon, a high tide. It happened to happen the week before a presidential election, all of which combined to create a massive storm surge up Long Island Sound and into New York City and the Jersey Shore. Now, our Department of Energy team warned about these risks and impacts 2 years earlier, in 2010. But even then, we were surprised at how the scenario actually played out. And the city of New York, to their credit, had been making contingency plans for the storm as early as 2006. The problem was that the critical factor was in the power system. Namely, these basement-level electricity transformers, and people refused to pay the costs of moving them out of their basements because it had never been a problem before. They simply couldn't talk about it to the public in the right way. Now, the example of the Fukushima Daiichi nuclear power plant in Japan is also well known. The 2011 earthquake was actually 3 disasters in one. Now, the first was the magnitude 9.0 earthquake. And for that, Japan was extraordinarily well prepared. It was better prepared for the earthquake than perhaps any country on Earth. The resulting tsunami, however, was far greater in magnitude than people had expected. And so when TEPCO, the utility in charge of the Japanese reactor, developed its disaster plans, it prepared only for what it thought was the most likely event. By not thinking of extreme scenarios and looking at how the system as a whole would respond, TEPCO unwisely placed its backup diesel generators right behind the seawall. Now, this vulnerability, or in military terms, a critical node, could have been easily changed in advance. However, instead, that loss of the critical node set off a chain of reactions that, in one way or another, will be felt for centuries. Within days, Germany had voted to shut down nuclear power stations in its country. Italy and Switzerland followed quickly with disavowing any future development, and energy geopolitics was put into place that made current events in Ukraine all the more likely, because it made Berlin that much more dependent upon Russian natural gas imports. Now, climate changes, Fukushima wasn't climate related, but climate changes are creating similar changes in the geopolitical landscape. As Tibetan glaciers melt, the future of downstream water resources in countries like India, Bangladesh, and Vietnam are put into question, which then intersects with existing development on rivers like the Brahmaputra. But you add additional climate pressures, and the situation can quickly worsen, such as instability in the West Indian monsoon. The monsoon depends on temperature differentials between sea surface temperature and the land temperature. And these are temperatures that we are changing both through land development and through rapidly increasing sea temperatures. So what scientists are witnessing now is a possible slowing of the West Indian monsoon. And should the monsoon fail one year, and this is by and large a nonlinear process, the consequences to food and energy security in India, Pakistan, and Bangladesh would be catastrophic, to put it lightly. It's a worrying scenario for military planners because the potential response is beyond anyone's capability, and the impact's too severe. But closer to home, even smaller changes can result in enormous impacts. Now, our Air Force team discovered preliminary scientific studies suggesting that even a half-degree change in sea surface temperature near the Hawaiian Islands could result in increased tropical storm activity. But the question was, well, so what? Why does that matter to the military? Why should the military worry about storms and shifting weather patterns? So, we carried out a number of assessments that found several key vulnerabilities in the Hawaiian Islands, notably at 2 port facilities. While the military forces themselves had contingencies in plan that would prevent most damage, the civilian infrastructure on the island of Oahu would be easily overwhelmed from a combination of potential events. Now, Oahu imports 95% of its electrical production through diesel fuel, through one port at Barbers Point. And almost all food is imported through the Sand Island port facilities. And both this location and Barbers Point would be inoperable under many of the scenarios. Storm surges made worse by rise in sea levels, loss of coral reefs would easily inundate the port facilities and the entire area of Waikiki. Likewise, Honolulu Airport, Hickam Field, and Keone Bay Air Station would be out of use for at least several days. And the consequences of this meant that with nearly 1 million people on the island of Oahu and 100,000 tourists in Waikiki, the military would be forced to undertake massive disaster operations, thousands of kilometers from the mainland. And this would not only be a major operation in and of itself, but it would affect logistics and operations elsewhere in the Pacific because the U.S. Pacific Command is based on Oahu. So both the military and the state of Hawaii recognize these risks, and they are investing now on renewable energy resources, which at least helps to mitigate some of the vulnerabilities associated with energy ports. Now, in August of this year, Hurricanes Iselle and Julio became the first major tropical storms to hit Hawaii since 1991. And they did it in quick succession, as the scenario suggested. But while Hawaii itself appears vulnerable, one purpose of developing these scenarios was to illustrate how vulnerable islands are across the Pacific. Now, with the steep reliance on dwindling fisheries, insecure water sources, and with few resources to undertake climate adaptation, many island nations and indigenous populations will face severe challenges from increasing combinations of climate change and loss of resources. But these changes affect Canada too. Not only is Canada involved in disaster relief operations themselves abroad, or affected by disasters in the US, such as Buffalo, but there are increased risks in this country. Even small increases in sea level, changes as small as a few centimeters, can greatly affect storm surge patterns in coastal communities like Vancouver. So while some people may wave away small rises in sea level as not being important, it's important to keep in mind that when you combine these changes in sea level to storm surges, potential tsunamis, and so forth, the overall risks rise significantly. And unlike the earlier IPCC estimates, which talked about sea level rise in terms of millimeters, we are now looking at sea level rise, global sea level rise, in terms of 1 to 2 meters by the end of this century. Now, the ability of these communities from BC to Newfoundland in adapting may be put to real test soon. But for affected communities, what structures or policies exist to help them adapt? And how can adaptation occur in a way that will not further damage existing cultural, economic, and social networks? Okay, now we don't have easy answers to these questions. But how to anticipate climate changes and impacts, and how to make them fit with existing realities, this has been the focus of our work with the Air Force and subsequent agencies. Now, climate change does not exist on its own. It represents increased energy in global environmental and geophysical systems, and therefore tracking single measures doesn't give us a real indication of how things are changing or how they might change. Ice melts, ocean currents shift, precipitation patterns change, ecosystems transform, and both humans and animals will migrate in order to anticipate these changes or adapt to them. The real trick is in shifting our perspectives from our own actions to the global consequences and impacts, back to a local focus in terms of what the local impacts are going to be, and then back out again in terms of why this affects global security. Admittedly, we're not trained to think like that. But let me give you some examples of how we actually do this foresight work and come up with something that's really usable for policymakers and for military planners. Now, the first step, and I'll give credit to colleague Carol Domain for this approach, is to ensure that all of the related military and intelligence work on climate change remains unclassified and open source. This runs against how things are normally done in any of those agencies. But it is simply impossible to deal with these issues without sharing information. And likewise, we cannot wait for CNN or the CBC to translate scientific publications for us. Instead, networks have to be set up in advance, and breaking people out of their stovepipes, breaking them out of their bureaucratic offices, of their academic departments, and finding ways for them to work together. Now, exactly how to do this is admittedly an enormous complicated issue. But it can work. It can actually work, especially since so many scientists and local experts feel very passionately about these issues, and they welcome any chance for policymakers or planners to listen to them. Now, to give an example, earlier this year, many of you, or many of us, saw photographs of large holes opening up in the Russian tundra. These were reportedly the results of massive methane releases from melting permafrost. There are equally concerns over methane releases in areas such as the Barents Sea. Now, methane releases aren't simply symptoms of a warming world, they're rather a tightening feedback loop. The more methane is released, the faster things are going to warm. And some of the first warnings of these methane issues were discovered by a joint Swedish-Russian research team operating in the Arctic in 2008. Now, by being engaged with the scientific community at an early stage, the US Department of Energy's climate security team was able to give a detailed written warning to Energy Secretary Chu by the time he was confirmed in his office in 2009, early 2009. Now, because of the nature of academic publishing, the associated article didn't come out until March 2010, and only then did media outlets start picking it up and discussing it. Now, likewise, because climate security is a risk issue, we can't use the same rules of evidence that we use in scientific or academic publishing. Now, in scientific publishing, one has to be at least 95% certain of results before he or she can publish. In complex issues with high amounts of uncertainty, that's really impossible most of the time. With tipping points, you can't wait until it happens and then publish it and say, see, we told you. Yet people, not just scientists, but also native elders and local experts, have enormous amounts of knowledge that could be used in these risk assessments. Yet too often, these people are never asked. Despite ground-up approaches being available, they're never asked to really give their impression on what the risks might be. So the next step is that we have to know how the weak signals and the tipping points really come about. Oops. Now, weak signals are bits of information that out of context might seem unimportant. I'm just hoping I didn't jump over a slide there. Did I? Okay, I'll go back. And my wife is in this photo, so I'm not allowed to skip over it. Now, the weak signals are bits of information that out of context seem unimportant, but to someone who knows the situation, it could be a precursor for something much larger. And tipping points are those parts of a system in which you can only walk so far before you fall off the stage. In technical terms, that's a phase shift. It's where things seem to be operating within normal boundaries, and then suddenly things shift to a different level of stability. Now, environmental systems are full of these, yet all of our policies, in fact, most of the climate change summaries that you'll see, rely on the assumption that all change is gradual and linear. But this isn't the case. It's difficult, but it is possible to establish a network to communicate weak signals and to identify these tipping points in advance. So let me give you another example. Our Minerva team, much like much of the US military, was reassigned in 2011 to Pacific Command. I was spending much of my time in Ottawa at the time, so I didn't really mind spending much of my winter in Honolulu instead. But while much of the team's focus was placed on issues such as water scarcity in China and India, and the continuing cleanup efforts in Japan, we began to wonder, are we being a bit myopic? Are we being a little short-sighted and not looking enough at risk to the United States itself? So we asked scientists in Hawaii about their current research, and we ended these conversations by asking them, what worries you the most? What's keeping you up at night? That's not a scientific question, it's a risk question, but it's an important one to ask because those conversations gave us the original impetus and the original framework for the Hawaii scenarios that I just mentioned earlier. It hadn't been published. It wasn't out there in the public domain, but yet the scientists were willing to share that information. And it was only by bringing experts and locals together in Hawaii to discuss this scenario that we could piece together a picture of what the future might look like and what that picture meant for military officers, planners, and residents. In identifying a potential geophysical change, however, one must still take this next step into identifying how these changes affect geoeconomic, geopolitical, or human security. And again, we use expert networks to help us understand what these impacts might be. Now, rather than just sit in our offices in Washington, D.C. or in Ottawa, the local impacts can only be understood by speaking to the locals. The Department of Energy set up a workshop prototype, which was then refined by the Air Force to address these cascading impacts and to help people create these scenarios. Now, this has been used by NATO, that's what this photo is of, by Pacific Command, the International Polar Year in Montreal, a number of groups. And it's been highly successful in developing future security scenarios. Because under this process, which can be done in as little as 1 or 2 days, diverse experts are brought together and forced to deal with the complexity of environmental energy issues and contribute their own knowledge. Most of these disasters, overall, are not what we call black swan events. They're not high-impact, low-probability events. Because the truth is that with climate, we are changing the probabilities. In technical terms, we're changing the boundary conditions of these systems. And that means that history is a very poor guide for the future. Just because something was a 100-year storm before doesn't mean that it is anymore. And most disasters aren't just one event in any case, but a combination of factors where planners didn't take account of how combinations led to greater impacts. On the contrary, most often we find improbable combinations of probable factors. Now, this is something that we're taught in flight school. We're taught that if you only focus on one thing, you figure I can handle that. Focus on another thing, I can handle that. But if you look systemically, you realize that you could be overwhelmed by this combination of small problems. Now, the other concern was that in translating scientific information into policy, how one defines the problem often defines what the solution will be. This was a real challenge then for the military. If, for example, we define a problem in terms of military action, then most of the solutions will likewise be traditionally military in nature. But if we are the ones who are creating the problem, we're not going to be advocating taking military action against ourselves. The tools have to be different. We have to identify things earlier in the process. Or as Einstein said, we cannot solve our problems with the same thinking we used when we created them. Another challenge we face in preparing for climate change impacts is that although we've developed tools to identify critical nodes and risks in advance, persuading people and governments to undertake investments is a real challenge. For militaries, the motivations are twofold. First, they're concerned with damage to their infrastructure, really their own stuff. Now, this could be naval bases, which by definition are built at sea level, air bases, or other infrastructure that could be affected by shifting environmental conditions. Now, to their credit, the U.S. services have undertaken serious reviews of all infrastructure around the globe. And they are making new investment decisions based on assumptions of severe climate change, sea level rise up to 2 meters by 2100, and shifts of precipitation water supply. Now, on the other side of the political spectrum, the U.S. House of Representatives has threatened to prohibit such planning quite explicitly. But to the Pentagon's point of view, this is simply their way of saving money in the long run and saving their operations and their strategies. The U.S. military can also be persuaded when it comes to changing operational conditions, the largest example of which, of course, is the opening of the Arctic Ocean. Now, this creates the need for greater patrol, search and rescue responsibilities, and in a very inhospitable environment. Operations can be affected in a number of ways, notable so-called mission decay, where environmental factors prevent forces from carrying out their objectives. Now, historically, perhaps the best known is Napoleon's invasion of Russia, which suffered notable mission decay from a combination of typhus and winter. But it can also be the case when energy supplies or logistics are disrupted, or when food supply is unavailable. And perhaps the best example of environmental logistics risks in recent years has been the 2010 Icelandic volcano eruption and the subsequent shutting down of airspace over Europe and the North Atlantic. Now, militaries are also called upon to carry out disaster response missions. And here again, there's enormous concern over the shape and scale of future operations. Disasters have already been increasing in scope and magnitude in recent decades, And climate change promises to increase these risks, especially as they combine with urbanization, increasing populations, and other factors. Now, the US motivation here is again monetary. When the US sends, for example, the 3rd Marine Expeditionary Unit into Philippines following Typhoon Haiyan, that comes out of the budget of the local combatant commander, in this case, Pacific Command, meaning it cuts into their budget of how they do combat operations or training. So the motivation for them is that the more disaster missions they have to undertake, the less they can be traditional warfighters. Now, I'm not making a judgment here over which action is more important, just that American military officers see their role primarily as being warfighters. And because of that, they have a vested interest in decreasing the number of disaster response missions they have to undertake. Now, that's an important thing to keep in mind, because this sort of logic, what is your mission and how will climate change disrupt that mission, should apply to other organizations and governments. That once you define your mission, it's much easier to identify how and when climate changes will negatively impact what you value most. Now, unfortunately, most organizations don't define their mission very well, nor do they take account of potential disasters and contingency planning. Defining clear objectives can help us break through the usual obstacles of uncertainty, of complexity, and it can help us to understand what we need to do and what needs to be accomplished. Now, I'll give you a simple example. Now, imagine you're flying into Pearson Airport, and as you're on final approach, the pilot comes on and she says, "We've had some indications that the landing gear might not be down. But historically, it's usually come down. So let's not worry about it." Now, of course, none of you are going to agree with that, right? Because everyone on the plane shares a common goal of getting down on the ground in one piece. Now, as a result of this, pilots are taught to act with uncertainty as if the uncertainty means that there is risk. And we react to uncertainty as if the more extreme scenario is possible, regardless of past history or probabilities. We plan for what is possible, rather than what we think is most likely. And that's an important lesson. However, the world continues to act as if we're still living in 1980s era climate science. And while scientists have long known that the climate changes would affect the Arctic earlier than other regions, the scale and pace have far exceeded any of the earlier predictions. So even in the northern boreal forest, smaller changes in air temperature resulted in pine beetle infestations, which have resulted in millions of acres of lost pine forest in Alberta and British Columbia alone. And further north, melting permafrost and loss of sea ice have and will continue to have enormous changes to the geophysical landscape of the Canadian Arctic. Now, the larger geopolitical risks to the Arctic, which receive much more media attention, they're really not as worrisome, at least to my team. And they're not as worrisome perhaps because they receive so much attention and because there are already governance structures such as the Arctic Council to deal with these problems. And nor is it merely infrastructure that's lost, whether those are ice roads or melting pipeline foundations, but rather the primary concern should be the communities and nations that have long lived in those areas. Climate security, after all, remains very much a story of human security. And the northern communities that experience climate change in addition to any number of pre-existing vulnerabilities. Now, to many Inuit communities, for example, these challenges, climate security to them is often described in terms of food security. The ability to hunt for country food, to provide for their families, has already been a challenge for decades, but it's now made worse by the loss of sea ice, shifting season, changes in migration patterns, loss of traditional knowledge, and extremely high costs of imported food. The Canadian government has used a variety of platforms to demonstrate the importance it accords to sovereignty in the North. Now, in traditional international law, sovereignty is demonstrated when a country's citizens live in and use a particular area of land. Yet even as we speak, climate change and the loss of Arctic ice are opening this region to potential outsiders. Now, it's in my view important for both human security and geopolitical security that those very people who would establish sovereignty for Canada, which really means the Indigenous communities that live in the area, that they be able to continue living there. So without even getting into climate mitigation policies, The ability of Canada to adapt to climate change depends upon two things, not exclusively, but two things I'll bring up tonight. First, it depends upon Canada defining the North and its peoples as real priorities, and providing a sort of guiding mission that helps to define climate security for the military and for other agencies and ministries. And it depends on Canada protecting the free flow of information, both in the scientific community and when discussing energy policies and environmental impacts. Climate security scenarios do contain numerous opportunities for action, particularly those which are taken early. But in order to identify those opportunities, we need to engage with the scientific community and the local populations. Historically, scarcities have led more to cooperation than to conflict. The Indus River treaties between Pakistan and India have survived despite numerous wars. And it's because the two countries understand that they have collective interests in protecting this river. At more local levels, protecting water supplies is one of the few issues for which Serbs and Bosnian Muslims will sit down at the same table together. And while we're told that energy and environmental policies are highly polarized, and that, for example, focusing on the environment will only cost jobs, this is a false dichotomy and a rather short-sighted one. Climate impacts are real and they will hit us hard. Even as some speak of a so-called warming pause, basic physics suggests that the Earth is continuing to absorb increased amounts of energy into its geophysical and ecological systems. Our task then is to help identify what these impacts will be, where the critical vulnerabilities lay, and how these cascading risks will affect us. But while the tools exist to help us see this future, the larger political challenge is in defining what we want to protect and in providing a political atmosphere in which these discussions can identify opportunities rather than only problems. I think these are challenges for which the Trudeau Foundation was established, in protecting human rights of vulnerable populations, promoting the sort of democratic values that go hand in hand with the free flow of information and collaborative solutions. Thank you.